Hello everyone, my name is Arif Emre Burhan. I am a second graduate student in Computer Science Engineering in Bilkent University. Today I am going to present my Physics 101 project. In my project I am going to examine whether the mass, release angle and the length of the pendulum does affect oscillation period or not. First of all, I need to introduce my equipments. Here is the list of my equipments. I am going to use the rope as a pendulum. I will tie the bottle to the rope and release the bottle. I will then use the chronometer to keep the time of oscillation period. I will use ruler, protractor, and precision balance to measure the mass, release angle, and the length of the pendulum. And here is the equation for the period of oscillation. As you can see, the mass and the release angle doesn't affect the period of oscillation. I'm going to try to show this. Let's look at my trials. Here is my first trial with these quantities, and then I'm going to change my length of the pendulum, and I expect period to increase. Here is my second trial with these quantities. As you can see, I increase the length of the pendulum and I expect the period to be longer. It was 1.30 seconds in the first trial, now it's 1.7. This is my third trial with different quantities. I decrease the mass and I don't expect period to change, but there is a small change in the oscillation period. I think it's because the human factor. And this is my fourth and the last trial. As you can see, I changed the release angle and I didn't expect period to be changed, but it decreased 10 milliseconds. It was 1.66 seconds in the third trial. Now it's 1.56 seconds. Because of the human factor, I guess, I couldn't reach my goal. In conclusion, if we ignore the small changes in the period of oscillation because of the imperfect conditions, we can conclude that while the mass and the release angle does not affect the period of oscillation, the length of the pendulum affect the oscillation period. Thanks for listening.